Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine watching a full-length documentary and then asking an AI what happened at minute 32 and why. Sounds easy, but today's models struggle badly. In the paper LVOmniBench, Pioneering Long Audio-Video Understanding Evaluation for Omnimodal LLMs by Keda Tao and Yuhua Zheng, the authors highlight a critical gap. Most benchmarks test short clips, seconds to a few minutes, but real-world content, it's long, complex, and deeply intertwined across audio and video. So they introduce LVOmniBench, a benchmark designed specifically for long-form multimodal reasoning. Think of it like giving an AI a full movie and asking questions that require memory, context, and cross-modal alignment. The dataset includes 275 videos, each ranging from 10 to 90 minutes, and over 1,000 carefully designed Q&A pairs. These aren't simple questions. They require combining signals across time. For example, first identify a character from audio, then track them visually. Then count how many times they appear later, like solving a mystery where clues are scattered across scenes. Now let's talk about how this dataset is built. The pipeline is surprisingly rigorous. Step 1. Collect over 3,000 videos from real-world domains like cooking, vlogs, and films. Step 2. Manually filter them based on quality, duration, and richness of audio-visual content. Step 3. Annotate questions completely by humans. Why manual? Because automated question generation often introduces hallucinations or shallow reasoning. The authors also define a taxonomy of question types. First, perception, basic details like objects, sounds, or counts. Then, understanding who is doing what and in what context. Next, inference, connecting events across time and space. And finally, logical reasoning, multi-step thinking across modalities. Each question is also labeled with difficulty, low, medium, or high. Now here's where things get interesting. Even state-of-the-art models struggle. Open source models, they barely cross 35% accuracy. Even a strong proprietary model like Gemini 3 Pro tops out around 65%, and performance drops sharply as questions get harder or require longer context. Why is this so hard? The paper reveals several bottlenecks. First, long-term memory. Models struggle to retain information across 30+ minutes. Second, cross-modal alignment. They often process audio and video separately instead of integrating them. Third, audio understanding, especially music and nonverbal sounds, which models frequently ignore. In fact, many models rely heavily on visual cues, even when the answer depends on audio. The authors dig deeper with error analysis. The biggest chunk, 34%, comes from perception errors. Then reasoning errors, about 23%. And localization errors, nearly 20%, meaning models fail to pinpoint when something happens. Another major issue, the cross-modal semantic gap. Models understand audio and video, but fail to connect them meaningfully. Here's a practical takeaway. If you're building multimodal systems, don't assume raw audio is being used effectively. In fact, adding ASR transcripts, basically text from audio, can significantly boost performance in open source models. But that's still a workaround. True understanding means capturing tone, emotion, and sound patterns, not just text. So, we are left with a big question. Can future AI truly watch, listen, and reason like humans across time? Because solving that is the next frontier of multimodal intelligence. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.